Hello.
Hello.
Hey, hello.
Hello.
Good morning.
Hello.
Hi, Sean.
Hi.
Gail, do you want to do your usual requirement to have people put in their name and affiliation in the meeting?
Sure. Thank you, Sean. Yeah, if you can just to help me out with capturing minutes, if you could update your name in the participants list to include your organization or your affiliation, you can do that just by clicking on participants, then clicking on your name, then clicking on rename. I have your names written down. I just don't know who you're all with. Thank you.
Tim is on his iPhone, so I don't know if you can change that, but he's from Hawkeye 360 as well.
Thank you.
Are you guys able to see my screen?
Yes.
Awesome. Yeah, let's start it. Welcome. I mean, there might be people keep joining, but we have an exciting presentation today, so I want to just get it kicked off. Welcome to joining July's UCF TAC meeting. For this month's meeting, we have external presenter Mike from Hawkeye 360 is going to introduce us to the amazing application that built on top of its GL. And we're also going to have some UCF membership and board updates and project transfer updates on the UCF projects. And in the end, we're going to have its GL development update as well. So let's get into it. Ib introduced me to Mike, and he is from Hawkeye 360. And they are building applications based on DeckGL and using their unique commercial satellite constellation identifies and process a broad range of radio frequency signals. So their application helps people visualize and analyze radio frequency data, and it's very exciting and looks very sci-fi. So yeah, Mike, welcome to the meeting. I know there are more people from Hawkeye joining, so welcome everybody. And do you want to go into your application?
Sure.
And presentation? Great.
So thank you for having us to show our work to everyone and share what we've been doing and some of the technology that we work with. I have a few slides just to give you a little background on Hawkeye and who we are, what we do as our core capability, and then we'll dive right into the application itself, talk a little bit about the technology that we use behind the scenes and the functionality that we implemented. As mentioned, I'm Mike Werling. I'm the Director of Enterprise Applications, so our group is responsible primarily for the customer-facing systems of our architecture. I'm joined by Hyun Seo. He is our principal designer, responsible for the sci-fi look, as you said, to the application, as well as Tim Pavlik, who's our vice president of product. And the development team I asked to join us just to be here to answer questions and see where everything goes. So Sergio and Jordan, and I'm not sure if Trinisha joined us on the line, as well as Chad Margata, who's our product lead of product for the application. So that's our team. We're happy to answer questions as we go and give you a perspective of what we've done and why we've done it. So Hawkeye 360, we've got a lot going on. We are a data analytics company, and part of our data that we do is what we collect ourselves from our own satellite constellation. So we launch small satellites. We have 6 functional in orbit right now, and they work in sets of 3 in clusters to do RF radio frequency geolocation on the Earth. We do a variety of different signals, and we work with a bunch of different domain areas to try to support situational awareness, understanding of patterns, and general providing this data out to a variety of different customers who can extract value and perform additional analysis on the data. So it's another Earth sensing model, but instead of imagery or radar, we're actually detecting radio energy emissions and then triangulating down on those. As mentioned, we have a satellite constellation, and they fly in a pattern of in a group of 3 to do the radio triangulation piece, but they don't actually talk to each other. They record their location, the precise time of sensing, and the radio emission energy, which is downlinked, and then we have backend algorithms that do geolocation based on those raw files. So you think of it kind of as an audio file captured by the satellites themselves, and then all 3 of them are combined and looking at the timestamps and the energy frequencies, able to tell when we have the same emission, and then based on the time and the mathematics behind that, the scenes there, actually pinpoint on the Earth where we think it's going to be. We say pinpoint and we show points a lot, but it's really an error area. We say it's kind of in this area to the best probability that we can determine. So you'll see some of that as we go through the demo. On top of that, we perform some additional analytics where we're bringing in other data sources, commercial ship tracking data, commercial ship information data. We do our primary focus initially is maritime domain, and we're moving into overland terrestrial kind of analysis as we go. And what we do is we deliver that data as files to customers. So initially we were assuming that customers would ingest that data into their spatial data infrastructure. They would bring it into their Esri platform or their QGIS or OpenGeo, publish it as their own WMS, build their own web apps around it. And we found there was still a gap. Some customers are sophisticated and do that kind of stuff, and some need a user interface and the capability to actually work with our data to get the best value out of it. So that's where the mission space application came from, was that need of some customers to have a platform where they could view the data. Our product team, specifically Tim, saw Kepler and was really impressed with the visualization capabilities of Kepler and the way that it worked. And we talked about it, and I said, well, Kepler is really good, but I think we're going to need a more customized application, and we could take the pieces that make up Kepler and rebuild them into our own flavor application. So that's how we came on to using DeckGL and the Mapbox capabilities under the covers. The intent of Mission Space is to be able to visualize the data, dig into it, and find mission-specific information related to the tasks they're doing, and then to look for patterns and really start to look at what are the things that we can then start predicting. So this is an early product. We've been we've been working on it for about a year, and we've made a lot of great progress, but we've still got a lot of capabilities we want to explore and build into the system. So that's kind of the top level view of what it is that we've done in terms of the capability that we're bringing to customers. The how we did it is not usually we talk about. Normally we just run demos and try to sell the software, but for this group, I'm sure we're interested in what's under the covers. We did develop it using TypeScript, React, and Redux behind the scenes with DeckGL. We use Nebula for some of the editing capability you'll see, as well as Luma for some of the rendering, fine tuning that we do. Behind the scenes, behind that, we actually publish our data as Mapbox vector tiles. So we have used TileStrata, an open source product, to connect to PostGIS and publish our data live as vector tiles. And then we ingest those into the deck using the MVT layer and a whole lot of custom rendering that goes along behind it. The TileStrata, we did customize a bit because we needed to add some query capabilities, some parameterization of the URLs so that we could do mostly the temporal requirements that we have for moving through time. Also backing it is a set of web services. Some of them are your traditional CRUD, create, read, delete, database kind of capabilities to maintain the state. We use GraphQL as our API primarily. We still have a few legacy REST calls that we use, but we've been moving into the GraphQL world for our API. And that's really the architecture and framework that we use for the application. Anybody have questions at this point while I change screens? Second two. So this is the Mission Space application that's running. This is the instance running on our test platform. And we break up the the user experience into what we call playbooks. So if a user is focusing on multiple missions, doing different analysis of maybe they're a fisheries company and they want to see the different fishery areas and they want to break them up so they can switch between them easily, they can build different playbooks. And they can even share those playbooks with other people in their organization. So you can have a bit of a collaborative sense to the application. start a new one. When the user goes into it, then they jump right into the map with an overview of the area, and you can see a lot of the features here that go into mission space. So the first thing everybody notices is the map, of course. And what we're showing there is a heat map style aggregation of the RF data. As everybody knows, when you have a dense point data set, it can be difficult to display it at a high zoom level to be able to extract any information out of it, because it becomes just a big blob. So what we've done is abstracted it out in aggregation to present to the user where data is that they might want to look at. So you can see that each box is outlined to show the quantity of data that's not currently visible in terms of filtering and different settings that you can have inside the application. You can see some have fill patterns, which show the density of data that is actually unfiltered and is visible. And some of the squares have a green dot annotating them. Some of our data we're actually able to extract identifying information about the vessel. In this case, it's called a MIMSI. It's a ship identifier that is broadcast by some of their data. So if we can extract that from our RF sensing, we record it, and then we can actually show the user where we were able to actually identify a ship. Up at the top, you see that we have a time bar. So RF data is very, very temporal in nature. We're taking pictures, if you will, or harvesting data. And the next time we harvest data in that same spot, it's going to be different. Things have moved, the emitters are different, capabilities are different. So as I move the time bar around, you can see that the underlying data reflects. We have two different time sequences. One is the domain, which is the query that is actually going to the backend and saying, give me all the data for this time period. And then we have a range where the user can actually play with that data. And that way we're not reissuing the query every time that they want to view data against different times, or maybe jump around in time, animate the playback. So actually sequence through the time. None of that is running server queries on the back end, except to maybe load new tiles if needed. So when the user zooms in and out, we're using the standard map tile retrieve capability. So you can see that the data actually refines and the aggregation decomposes into smaller blocks as you zoom in. You get down to a certain zoom level, you can flip over and actually look at the icon view of the data. So now we can see the actual elements of data that made up that square and the quantity of them. So you can see we have some X-band radar, some L-band satellite phone detections here. Let's see if we have anything like that. You can see down here, I've got the different signal types that we can turn on and off. So I can actually do that filtering. Not really interested. I'm really interested in voice communication. So there was a VHF hiding in there, signal. Let's see. We do have some of your basic base map configuration, so you can switch between satellite view or simple view. We were looking for map backgrounds that didn't distract from the data. It gives you enough context to know where you are in the world between the mini map and of course the main map, but without overloading the user with a lot of information. And they can choose to go and turn on more and more labeling and information if they choose to get more and more context for their map, or they can turn it all off to really focus on a certain level of data. There's an interaction model for everything. So now we start looking at some of that analysis. I clicked on this VHF hit, and we can see that it is from July 21st, 0800, 0849 UTC. It was channel 67. So we're taking the frequency and parsing it into the channels that VHF uses. And then we're going out to another data source saying, what are the commercial service providers giving us to say what ship tracking is in the area? So our VHF doesn't have anything except there was
the state that we're tracking, like that you want to.
Sorry, go ahead.
Great.
Was there a question? I couldn't quite hear you. Okay. So now we can start pulling in information from another source to say, these are possibly the vessel that did this discrimination because the commercial providers who get the beacon traffic from the vessels say that they were reported along these points right here and this point here. So we can see that this ship from Hong Kong is one of the vessels that was detected, and we can actually pull up additional information on that ship. So we can see the owner, the detection information from Hawkeye, and dive into some of the details of that vessel. We have some other information that we extract from that. What we call insights are things like dark ships and ships that stop broadcasting their commercial beacon, maybe turn it off, or maybe they had a software glitch or something. And actually, now you can see we actually start populating some of those dark vessels. These are ships that weren't detected by that commercial AIS, the commercial ship sensing provider. So you can find the same kind of information, and now we start loading track information to say, where were those vessels in the past? So you can actually start to see where they came from, and then the sequence that they brought in. We also have rendezvous, which are vessels that were in the same area, going the same path and doing with a certain distance and a certain speed. So again, the internet action to highlight and determine where they are. We go and look for them in other identified areas. So you can see that there's multiple highlights on here. So these vessels were actually detected in multiple places. And, track data. Oh, there we go. So here's another set of rendezvous with the same or similar vessels. So there's a lot of data processing to go look up where things are, where similar things are happening, load auxiliary data from other sources to bring in and see what other behaviors can we find for those signals. Over here on the main tab, when I'm not selected on anything, you can also see that we're counting. We're giving the user statistics on what they see on the map. So in this case, there were 7 L-band detections. We'll turn on X-band. You can see the counts are updated and they're live as we move the map around. Blackish. There we go. Now you can see the counts are updated to reflect the actual data in view. User has the capability to annotate the map. So this is where our nebula capability comes in to actually draw shapes and say, maybe there was something interesting. Change the color, do some of the different settings. So this is where I might want to bookmark a spot and say, there was an interesting event here. There's something I maybe want to go look at. Or if this is a shared playbook, I could actually annotate here and other users would see this annotation and know that I wanted to look there and found something interesting. I could even take this and mark it as a geofence, and we have an alerting capability that would let me create alert rules in the system that would watch for signal detections. And I can pick that geofence and say, I want to be alerted when the system detects any of these signals in that area. And what actually happens is that is a server-side alert. It's now published to the server and it's running. So even if I log out of the application, that definition will still be checked against our data. And if some new data comes in that matches the criteria, I would start getting that information over here. And I also might get an email if I set those configurations up so that I know, oh, new data came in, it's got a link to this playbook in it, and I can click on it and jump right into my map analysis and see where that data is. We also have the concept of watch lists. Let's go find somebody. We can set up a list of vessels that I'm interested in watching, and then I can quickly zoom to those vessels, see where they are on the map, and do different tracking and consideration of those. And of course, during demos, it never comes up.
Seems like there are a bunch of dots, the green dots in Asia.
Oh, are there? Oh, yeah, there are some over there. Thanks, yeah. Drop down and see some identified RF data here. Jeff? See, again, we get the correlations, but in this case, we have a MIMSI, a ship ID. I can favorite it, and it appears up over in my list. I can zoom to, I can look at the vessel card. In this case, our catalog doesn't have anything for that ship ID, but we do have different detections that we bring up, so you can kind of see the patterns. I don't know, Hyun, do you have anything you'd like to add to?
Yeah, I think only thing that wasn't covered was just a heat map selection. You can like select the heat map squares. Each of those squares are clickable, so the user can see at a localized statistics on that area. And the idea of snapshots. So like for example, if you click, yeah, whatever Mike just clicked on, the snapshot icon, what this is for is missions are never, I want to find something and I find it right away. It's a process. So what this is for is as the analyst kind of, you know, puts in different actions in the application, they can continue to click on that snapshot icon and basically go to a read-only mode where it'll take them to where they were at the spot where they clicked on the snapshot icon. So they can kind of flip through it like a presentation of this is, if I find something interesting, I click on that and I can always go back to it. And the idea is showing it off or sharing it with somebody else so that they can go and mess around, kind of like a more in-depth screenshot, if you will. And they don't have the fear, you don't have to fear about messing up anything on the active session.
Thanks, Jim.
Oh, and the time opacity might be the cool one. I think the only one to show the left. Yeah, the assign time to opacity in the icon view, I think would be the cool one. I think that's like the that actual feature was the reason why we went to DeckGL.
Yeah, we started out with Mapbox GL, just straight, trying to do it in just Mapbox GL, and then some of these rendering capabilities we need to deal with that we just couldn't meet easily there, and we're able to do under Deck.
Do you have the filters turned off by any chance? Oh, it might be all dark ships.
It's the precision.
Oh, did the precision hit us again? There we go.
Oh, okay.
No,
oh, do you want to go over that real quick?
Yeah, so I did mention that our data, even though you see points here, let's get down to actually seeing some points. The data itself, and now you can see kind of that opacity set to the more faint points are older in terms of this timeline, as opposed to the brighter points are the more recent ones. So it gives you an idea of within the 65-hour range, where did time hit, where did data hit, but we can actually turn on the precision markers. Yeah, and then just now you can start seeing these are the actual error ellipses associated with the RF detection. So it's the center point is what we display with the icon, but it's actually somewhere in 95% probability that it's somewhere within this this ellipse. Some of the data, depending on the satellite geometry, might have larger ellipses. You can see this X band over here is a little bit larger. But of course, our processing team is constantly working to drive up our accuracy and drive down the size of these error ellipses. So it's as a customer, I could say, well, I really want to focus on the super precise, best precision that you've got for the data, and filter out anything by that error ellipse area. And then it's not area, it's the semi-minor, semi-major axis, so the biggest axis of the ellipse. back to technology, we run all of our servers are hosted up in Amazon Web Services. Stand up sub accounts, specific instances for different customer organizations instead of dealing with a multi-tenant kind of architecture. So it's definitely been a learning experience, but we've been able to find a lot of value from the libraries like DEC and Kepler and Mapbox to be able to do this. So I believe that would conclude the demonstration and the discussion. Any questions?
This is amazing. I have so many questions. So just so we're open up the floor for open questions. So jump on in. So I do have one that on a high level, I think. Can you tell, because this is like LF detection and then ship tracking, it's kind of new domain, at least to me. So can you explain a little bit about, what are some of the use cases of your application and how are you a customer using this?
Yeah, some of the use cases are, one of our big one is fisheries, and I don't know if I have Tim's demo up here. I have it, but to be able to look at areas where there are fisheries that might be in jeopardy or fisheries that are being poached on, and to be able to bring up the commercial information to look at, say.
Oh, it might be also cool to show the maritime map, Mike, with like the EEZs and
Oh, yeah. So now you can start to see some of the economic zones of different countries, and we can start to look over time at where shipping is occurring and start to look for patterns and identifying vessels that maybe are in the area. And he's still on the line, but he has a demo I don't have present with me right now, but where we actually see a lot of vessels along the outside of this EEZ around the Galapagos Islands. We see a lot of traffic here, but then those commercial beacons go dark within the zone. So there's a lot of ships outside, and then the Hawkeye data. So a ship may stop broadcasting their beacon that they're legally supposed to. Say, here I am. It's a ship safety kind of beacon that they can broadcast and other ships receive. But of course, if they're going to go somewhere they're not supposed to, they'll turn that off. But they leave their radar on. They still use VHF, push-to-talk radios to talk to each other. And those are the signals that Hawkeye detects and says, well, there's corresponding activity here. You can see within the EEZ. And in this case, it's an L-band. So there's a sat phone in use right there. Is that somebody who's supposed to be there or not? That's part of what the analyst can do and start to view that. And in fact, identifying rendezvous that happen outside of the EEZ, because fishing vessels don't necessarily go back to port every time they finish their catch. They rendezvous with a refrigerator ship, and then they rendezvous with a tanker. And see.
Hey, Mike.
Yeah, Tim, go ahead.
The shared playbook is Tim's snapshotty playbook. You might have to scroll down a little bit.
Oh, there it is. Yeah, sorry.
And then in the snapshot list, you'll see the one that says Galapagos. I think it's the first one. And each snapshot's labeled. There we go.
Yeah, so in this case, Tim, you probably run it better than I can at this point. Why don't you go ahead and I'll just drive.
Yeah, what we should see if the signals, you can advance to the next. I don't see any data in there. Here you go. Okay, so I put a dark red line around a blob of vessels. You're like, what's up with this? And it's along the bottom of the exclusive economic zone. You can see of Ecuador. So Mike, if you shrink the timeline back to just a couple of days in the beginning. Yeah, one really cool feature these guys did was put in a play button. So it'll march it along at these increments. So go ahead and hit play. What we're going to see is this fleet of Chinese vessels, and you know that because you look at the flags to the lower right there, goes along the edge of the EEZ. Later, we'll show you that they go inside of it, but here they stretch out and they say, well, we're done there. Let's go over here to the Ecuador EEZ, and then they'll move down the coast. So you can stop the play button. You can drag it back to the beginning. Yeah, open it up all the way and you'll see how many Chinese vessels. You see the flag dynamically changes there. Can't read it from here, but I know it's like 140. So if you shrink it down, Mike, just to a couple of days and zoom in, switch on just rendezvous. Good. Yeah, actually go to the next snapshot. There's a rendezvous snapshot in here. There we go. And we zoom in there. I annotated it. Mike was talking about annotations earlier. Can't see if those are rendezvous on my phone, but are they? There we go. You can click on any one of those rendezvous and you see those are two vessels that are co-traveling with each other. And Mike can show you the baseball cards because what we'll see, there's a preview there, but is that a, turn my phone this way.
Fishing
Okay,
vessel.
fishing vessel. Then you go to the other one. It's likely to be either an oil tanker or a reefer ship.
Yeah, these are both fishing.
If you can zoom out a little, the annotations will show you where they are. But what we're able to find in just a few clicks with these rendezvous was that there's a whole fleet of Chinese vessels, like 140 of them down here.
Yeah.
Many of them are fishing. There's a reefer. Is that a reefer ship?
Yep.
Yeah. So they offload on the refrigerator. They get they gas up with the oil tanker, and they keep going. Now, if we were to go back, open up the time frame, turn off analytics, and turn on signals. So now I'm turning off my rendezvous. I'm going to turn on my signals and watch the line. Oh, look at that. Now you begin to see we have X band, which means our vessels navigating on the other side of that country line, and L band, which means there's mobile sat phones in there as well. Now they've turned off their AIS and they think you can't see them, but Hawkeye's radio frequency data picks them up. And we even got one of our business partners, Airblast, to do a synthetic aperture radar shot of one of these, and you can see it's a fishing vessel. So what we think is really neat about this maritime scenario is it shows a pattern of life with, and the last thing, Mike, maybe you could just show dark ships, because here are the things that you can see in AIS, but look at that. It's just crazy, the amount of dark ships. That's them going off their AIS. And so the dark ship fishing all along there and then over the EEZ. And I'll hand it back to you, Mike.
Thanks, Tim. So that's one example of a maritime scenario around fisheries. We've done some terrestrial stuff along national borders, looking at different patterns there. We've done oil and gas, kind of the SCADA.
Can I have just a quick question about this? Is so fascinating. So I know with the AIS data, you can capture call sign, a lot of information about the ship, but how would you able to determine from the L band or X band that this is like a Chinese ship with the information you show below? Are they also contained in the LF data?
No.
Well,
sorry, go ahead, Tim.
Yeah, well, we got the SAR data for that. What it does is the Hawkeye data will queue another source of intelligence to take a look. There are indicators in L band as to what the phone number is and stuff like that. We don't pull those out of there, but we're moving toward where we can identify the radio wave itself. So that's where we're headed, to identify the unknown signals, the ones that don't have a MIMSI.
So in this case, we don't know that this L band was a Chinese ship. It's up to the analyst to say, oh, I see this traffic. I see a lot of vessels with the Chinese flag, but I don't see anything over here in the terms of the commercial, the beacon broadcast, but I still see ships doing something over there. So that's where the analyst would then take it to start determining what's going on. Maybe it's benign, maybe there is something legal going on, or maybe not.
Yeah, in terms of the narrative, the associating an L band that is not identified to something else would be actually a good use case of, like, there's a little download button up in the top right corner where it would just export all the dots that the analyst is seeing in a GeoJSON file, and they would put that in ARC with an overlay with SAR, for example, to make that determination. That is something that we're looking into right now, but that's kind of the out of app analysis that the analyst would have to do currently.
Got it. Thank you.
Sure.
You're welcome. Great question. Thank you.
So the the analyst you're referring to here will be some kind of ocean association that's supposed to regulate illegal, marine fishing activities.
Great. I mean, this is a demo we generated to kind of highlight the capabilities. But yes, we're a commercial company. We sell the data to US and international markets in a variety of different domains. So, fisheries, and what's that, Tim?
This is Ib. Can you hear me?
Yes.
Yeah, sorry. Just when your presentation concluded, I had a power outage, and I'm trying to reconnect here with my iPhone network. So, I just wanted to give you some comments on this. As the kind of original creator of DeckGL, it's just incredibly gratifying to see that, what you guys have built here. We took lots of pains to design this. It's a kind of a composable, an extensible framework to, allow this type of really customized experiences, and to see someone be able to do that with these frameworks and do it in such an incredibly, beautiful and compelling way. It's just it's a huge seeing what you've done. It's amazing. I love the entire design. I can see what you've done, how you've used the frameworks, and I think the end result is beautiful. From the UCF hat, I would say that, it's great that you're here. I mean, the reason why we've taken all of this into this, not only open source, but into open governance, which is what the Urban Computing Foundation here is about, is to make sure that those of us who build on these things, on these frameworks, that we have the ability to make sure that these frameworks, continue to, exist and be supported, and so when we're building products, and making big choices, right, then being able to have this technical foundation, to be, vibrant and to continue to be supported. And also, obviously, through this open governance process, we provide a path to become a contributor and to kind of have an influence and so on. And so, and obviously, you've done a lot of custom work here, and some of that may be things you want to be proprietary, but we're also always looking for, I mean, this was built by contributions from people like us. And so that's one of the suggestions I had to June, that, perhaps you'd like to be able to bring some of these things back into the frameworks. And if you were interested, then, we would love to have that discussion with you.
Yeah, we'd love to continue that discussion. I mean, obviously, we're heavy users of the MBT layer, and I've posted on the Slack forums. Trying to do this aggregation in a tile format is a very interesting problem. We actually solved it in this version by pushing the aggregation off to server side. So this map layer that you see here is actually aggregation through a variety of database queries. But now that we understand DeckGL and the models a little better, we're looking at, could we do it client side instead, to give us much more flexibility in what rendering we can do with this view. And I will say, yeah, it's been an excellent tool, and we could have done this without DeckGL, but we wouldn't have got it done in, I don't know, Tim, how many months did we do before we had the first version? I think like 4 months, I think, something like that, before we were able to get our first view up to say this is actually possible.
Yeah, it's pretty incredible. when we show this, we say, well, sometimes people ask you, what did you do during COVID? And we went from a green field to this application, which is a pretty beefy 1.0. And without DeckGL, there's no way that would happen.
So thank you to the team of developers and everybody who's supported it. It's been really great.
Yeah, and I mean, in a just an area like the MVT layer, right? It's in a DeckGL itself is, it's a very big framework today, right? It's been development for 6 years, and the MVT layer is just starting to become, very sophisticated. It's multiple companies. We have huge contributions from Kato, for instance, into providing, binary support, and we see, there's a lot of users out there who really need this capability of being able to do really sophisticated things with the MVT layer to kind of do, things like, that you want to do dynamic aggregation of data on client side. I mean, one thing that would obviously, as you say, improve your experience is to get this back-end round trip whenever you zoom in, right? I think that is something that DeckGL can potentially help you with. So. Over the accumulation of all these contributions, it'd be very hard for one company to take this all the way. But together we're building on each other's, improvements and continuously, leveling up the capabilities. So.
Yeah, I will say one of our next iterations or tasks on our list is actually to move to the new globe view experiment that's happening in DECK. We do have customers who are working up, in the Arctic, in the North Pole, and web Mercator projection isn't all that useful when you get up to that area. But if you bring it into the globe view, it actually starts to look a lot better and be a lot more useful for those.
Yeah, I'd love to engage with you on that. I mean, there's still problems because vector tiles, still don't cover that area even with the globe view. We also have experiments where we support other types of projections that I could show you.
That would be great.
So basically, you could still use flat maps, but have non-Mercator projections. So there's a question of what type of input coordinates do we support and how do we project them on the screen.
Yep.
And I'd love if there was someone who really wanted to dig into that. We know what to do, but it's a bit of work. But that would be an amazing new capability, I think, for the framework. So
dateline issues, of course, we're looking a lot, and we hit data wrap issues just like everybody else does, I'm sure, in terms of when you hit the anti-meridian. Some of your data is over here, and then the analyst might have to, so recentering maps, reprojecting, and doing some of those tasks to.
Yeah, that's we have basic support for that with our wrap longitude feature, but
right.
This. So yeah, these are the things that takes by implementing these things, we really take this into really a production kind of caliber framework, right? I mean, doing a little bit of visualization is easy, but handling all these edge cases is where it gets tricky. So it's amazing stuff, very inspirational. Thank you.
Any other questions? Several of us are on the DeckGL Slack channel. If you want to reach out to us there, you can
I had a
chat.
quick question. I had seen a couple of YouTube videos about like fishing near Iceland recently, and it really seemed to be touching on the same fishery kind of description, but it's mostly, it was going over like decades of history.
Yeah.
And I was just curious if that is like similar kind of work that still goes on today. Like, is that the same thing as dark fishing in places, or I don't even, like, is this a tool that's helpful to folks like that are trying to control their cod fishing?
Yes, absolutely. I mean, that is
I can comment on that. As a matter of fact, Global Fishing Watch wants to team up with us to do illegal fishing. It's like illegal, unregulated, and underreported is the category, but yeah, it's very useful.
Yeah, we're more data to add to the analysis, and we're really exposing activities that are normally hidden, right? We're looking at it in a different way imagery can do that, but of course, imagery, you've got a much smaller area that you can survey with one image capture, whereas one survey for us for a given signal might be horizon to horizon. So it can be a much larger snapshot of what's going on that then drives the next level of analysis and feeds into, as Tim mentioned, maybe.
You might be interested in another one we did with Garamba National Park in Republic of Congo. They were having problems with poachers, and so they had us fly over the park. Only animals and rangers are supposed to be there, and they know what they look like. And we got some mobile sat phone activity in the park, and they went out and confirmed that there had been campfires there, so it was either rebels or poachers. So they found it very useful as well.
It's really interesting. My last question we might not have time for, but I'm really curious, just looking at your UI, it's very well designed, and there's like a lot of custom cohesive elements both on the map and in all the Chrome kind of around the map. And I'm very curious to just hear about design process, and approach to that, because it's hard, and I think that you've got a great execution.
Thank you, but a credit for that, Hyun. I
Yeah.
agree it's hard, and that's where he comes in. So.
Yeah, so I would say, in short, I guess as an Easter egg too, if anyone plays RTS games, real-time strategy games, like it's heavily inspired by StarCraft. Like I'm Korean, so StarCraft is like our national sport. So, but like what I really loved about games like that was the visualization was the core element where you need to focus and react to it really fast. And the difference between, I think, what you see in Mission Space versus other map tools is the absence of when you click on something pops up on top of it. It's always contained on the bottom or some kind of fixed place. So whatever, there's a couple things. One is in terms of the visual, it is expecting something at the same place, whether it is specific data or aggregation data. And in terms of the UX, I would say, well, actually that kind of extends to the UX too. Like basically nothing the user clicks on or does, when the user interacts with the application, for example, there's like a pin icon that Mike talked about where it takes the user to some place. If that's out of scope for the date range or the date domain, it would ask the user if they want to go there rather than just taking something. So that's kind of a first design principle, was never do something with an assumption of what the user wants. And two is having a basic, what you said, the Chrome, not a movable Chrome, basically. That might have to change later on because people want to put things on top or annotate them further. But at least in the first iteration, it was about putting information where the user can expect it in a consistent basis. And then the third would be, I think this is kind of one of those evolutionary things in design, is you saw the icon sets, the color scheme was pretty heavily thought out. So whenever Mike clicked on something, it was a bright pink, and that was reserved. That color is only reserved for something that the user has clicked on the map, versus when there was something associated, like I think there was like another ship that shared the same identifier, that is always going to be in purple, a darker shade, like an indirect, something that the machine produces, and then it tells the user, hey, this is something that I also saw, you might be interested in it. So color coordination was a big thing. Yeah, consistency in terms of information displacement, and it's like not automation, or not stopping automation, but just not assuming what the user is going to do, not oversimplifying it, basically. Be simple, but be also transparent. So I think those were the big design elements. And yeah, I think in a nutshell, those three would be it.
Okay, that's awesome. I think we have a few slides of the standing agenda, and we have only 5 minutes left. So
sorry about that.
It's very inspirational. Thank you. It's great to have you here.
Well, thanks for having us, and we'll
Sean, can you
look forward to talking further.
Can you put the final updates so we just go through them quickly? Okay. Do you want me to present, Sean?
I can go through the updates. So on the UCF side, Foursquare has officially joined the UCF as a member, premier member. So, and it was appointed to be on the UCF board, also the chair of the UCF board, starting until end of 2022. Welcome and congratulations to IP. So we're currently reviewing our next year budget and, hint, hint, Chris Gerben. So, but I think we're on good track of having enough budget to cover next year. Obviously, the more the merrier. So if you want to become a member or in the process of achieving it, let us know. Next thing, yep.
Yeah, so we worked for a long time on the 8.5 release. So VisGL is the kind of umbrella name for all the frameworks, and it's numbered in sync with DEC. So DECGL 8.5. All the dependent frameworks are now released officially. So Loaders GL3 is out, Luma GL 8.5, Math GL 3.5, and I think the final beta of DECGL 8.5 is published, and I expect this will be, the official release of DECGL 8.5 is imminent. Obviously, other downstream frameworks also need to update. I know it started in some cases, and it's a good time. We usually every 4 months we have an open governance planning meeting, and I think it's been a while, so we see if when Shoji is back, if she can, we'll get this organized. Obviously, we can look for identify areas of interest in that meeting, and there's just a couple of ideas here. So with collaborators, I hear Mapbox vector tiles could be another area from this. Next. So the goal is also to grow, obviously, the Urban Computing Foundation with new relevant projects. Ilya Uyandin has been transferring FlowMap.blue, and I think that he's out today, but I think the sense here is that this will become a new top-level UCF project. It is kind of a VisGL extension for flow maps, but it's a project that's managed by Ilya, so maybe we'll not do that as part of the VisGL open governance. Next. I believe Hubble GL transfer is in progress. I have not had confirmation that it from Uber to UCF. I haven't had confirmation that it has completed the video generation framework. We're very interested in Nebula, and I understand also Hawkeye is using it. It's still not transferred into the foundation. It has been proposed, but I don't think there's progress. It doesn't really have an active maintainer, so we have a little bit of an issue with Nebula. There's a lot of good PRs and contributions, but there's a gap there. Next. Also, some of the kind of foundational frameworks are still Uber frameworks. They're open source, but not part of the open governance. And we're thinking about how to handle this situation. I don't think we need to go into the detail, but ideally, UCF would be kind of complete and consistent, and so we can comfortably manage both the governance and also like the addition of access and other things to these frameworks without involving other companies. And finally, obviously, we're always interested in building out the foundation. So if anyone has projects you would like to contribute, features you would like to contribute to existing projects, other projects you would like to see added, I'd personally love to see an open source basemap library. We do have MapSen, but it's not under active development, but there are many other ideas. So, and I think this is the final slide.
Awesome. And yeah, in terms of, I think, open source libraries I want to add, just again, emphasis on this point that if you work with anything in the past that you think is relevant to Urban Computing Foundation, please let me and Ip know, and we will actively reaching out to people that own these projects to see if their willingness to contribute to UCF.
For proposals, is it best to have, you know, a working implementation outside of the foundation up and running and kind of established before proposing it to the foundation? Or do proposals come in the form of like really early stage projects as well?
I think we welcome projects at any stage, and obviously it has to be first have some code and open source, and not even maybe if you want to open source, and you know the thing is we are talk about the legal perspective that, but yeah, in general, we usually project will grow as they joining the foundation, and DECGL and Kepler's grow so much, I think for a couple of years, and so yeah, at any stage it's welcome. Any more questions? All right, thank you everyone, and thanks again for Michael, team here from Hawkeye to present. It is a very inspiring presentation, and for the attendees, if you see exciting projects like this, remember to drop us a line. We will always welcome people to come and talk about their project build with our framework. And with that, and thank you guys. We'll see you next month.
Thanks again for having us.
Yeah, thank you very much. It was nice meeting you all.
Thank you.
Too.
Thank you.
Presentation.